Hello and welcome to this circle theorems revision session. So we're going to be working on a series of questions. So I'm going to give you a question and give you some time to work on it, and then give you a good explanation as to how to go about calculating. So first of all, we're given this circle. And it says that angles A, B, C, D, and E are all points at the circumference of the circle, as you can see. It gives you angles BEA, which is 25 degrees, and CDE, which is 95 degrees. Now, it asks you to work out the size of angle BAE, which is this one, and angle CBE, which is this one. So I'm going to give you a bit of time to work this out. Feel free to pause the video and then play for an explanation. Also says to give reasons for your answer, and I want you to do that for B as well. Right, so feel free to pause the video. Okay, so firstly, the first thing you could do to go about working out angle BAE, would be to spot that these two lines here, BA and EA, are equal in length, as described by these two lines here. This means that this whole circle here is in fact an isosceles triangle. And because you're given one of the angles here, 25 degrees, you can work out angle here, the angle here EBA, which will also be equal to 25 degrees. And with that information, you can work out angle BAE to be 180 degrees minus 25 degrees plus 25 degrees. This will equal 130 degrees. Now, I've taken away the two calculated angles from 180 degrees because of the obvious fact that angles in a triangle add up to 180 degrees. Now, to give reasons for your answer, you'd simply state because of angles in an isosceles triangle, and that would be your answer to question A. There may be other ways of working this out, but this is one of them. For question 1b, you're asked to work out the size of angle CBE and give reasons. Now, firstly, you can see that there is a quadrilateral here, and all of the points are in contact with the circumference. So points B, C, D, and E are all touching the circumference, and this makes this quadrilateral here a cyclic quadrilateral. And this relates to one of the theorems which will be used. So the theorem states that opposite angles in a cyclic quadrilateral add up to 180 degrees. So then you can easily see that angle CBE will be equal to 180 degrees minus 95 degrees, which of course is equal to 75 degrees. And if you want to give reasons for that, you'd simply say because of angles in a cyclic quadrilateral. And that's your answer to question 1. So feel free to mark it and see where you went wrong, and hopefully learn from this question. Right, so moving on to question 2. We're given a circle and a triangle within the circle. It says that points A, B, C, D, and E are 4 points on the circumference of the circle, as with question 1. It says that ABE and DCE are straight lines, and that angle BAC is 25 degrees, and that angle EBC is 60 degrees. So I'm going to give you a bit of time to work on this. Feel free to pause the video. And then part C, which is the sort of extension section, says that a person called Ben says that line BD is the diameter of the circle. And then it gives you angle CAD, and you need to state why he is either right or wrong and give reasons. So feel free to pause the video now. Right, so first thing you should notice is that the angle here is part of an angle on a straight line. So you can see this straight line here, and it gives you this angle of 60 degrees. Now, because you know that angles on a straight line add up to 180 degrees, you know that the angle here is equal to 180 degrees minus 60 degrees, which is equal to 120 degrees. And because of the theorem you used in question 1, that opposite angles in a cyclic quadrilateral add up to 180 degrees, you know that the angle here is equal to 180 degrees minus 120 degrees, which is equal to 60 degrees. And that's your answer to question 2a. Now, when it asks you for ADB, it's asking you for the angle here, sort of smaller angle. Now, the way to work this out is to realise that the lines here, so here, 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 and here, form the bow tie shape of theorem. The bow tie shape of one of the theorems, and with the bow tie shape, or the angles, or the angle subdued by a chord in the same segment, you could see that the angle here is equal to the angle here, meaning the angle BDC is equal to 25 degrees, because, if you were asked why, because of angles subdued by an arc or chord in the same segment. Right, so with this, you can see that angle ADB will be equal to angle ADC minus 25 degrees, and angle ADC we worked out as 60 degrees, to be 60 degrees. So ADB will be equal to 60 degrees minus 25 degrees, which equals 35 degrees. And those are your answers. Now, Ben says that BD is the diameter of the circle. Sorry, it's getting a bit messy. So you should have stated either yes or no, and if you stated no, you'd be correct. Because it gives you the angle here. It gives you this angle. And it says that that angle is 65 degrees. And because of one of the first theorems you learn, angles in a triangle in a semicircle, you know that an angle in a triangle in a semicircle is always equal to 180 degrees. So, this kind of thing. That is always equal, to 90 degrees. Did I say 180? 90 degrees. And as CAD is the sort of equivalent of this angle, it says that this angle is 65 degrees, and that's how you know that this line here, should I say here, is not the diameter. So you'd say, because angles in a triangle in a semicircle are always 90 degrees. Perfect. Right, that's question 2. Done. Feel free to correct your work if you've done anything wrong, or mark it right. Right, so moving on to question 3. Right. Question 3 states that A, B, C, D, and E are points on the circumference of a circle, as with the 2 previous questions, with center 0. And it says that BOD is a straight line. That angle COD is 70 degrees. Now I ask you to find the angle of side BAD and to give reasons, very important, and to give reasons for when you find angle CBD, which is this one. So we're working out these two. Right, so I'm going to give you the opportunity to pause the video and have a go for yourself, and then I'll give you an explanation later. Right, so the first thing you'll notice is, as with question 2, that there is a straight line here. And that they give you one of the angles on the straight line, which is 70 degrees. And so from that, you can easily work out that this angle, BOC, is 180 degrees minus 70 degrees, which is equal to 110 degrees. Now you can use this. You can use this to work out angle CBD, which is, because you know that these two lines are the radius of the circle, you know that they are both equal in size, and therefore this triangle here is an isosceles triangle. Because of the nature of an isosceles triangle, these two angles here and here, will be equal to each other. And therefore, they will both add up to this angle, taken away from 180 degrees. Therefore, angle CBD will be equal to 180 minus the angle worked out previously, 110 degrees, divided by 2, because these two angles are equal to each other, and there's 2 of them. So this is equal, this can be simplified to 70 degrees by 2, or 35 degrees. And that's your answer for this one. Sorry, I worked out, I explained it in the reverse order. Now, if you wanted to work out BAD, you'd see that this straight line here runs through the centre of the circle, O. And that means that this line here is the diameter. Because of the theorem I explained earlier in question 2, this angle will always be equal to 90 degrees. If you wanted to give a reason, you'd say because of angles in a triangle in a semicircle. And for this one, if you wanted to give reasons, you'd say angles in an isosceles triangle. And that's your circle theorems revision done. I hope you learnt from the video, and yeah, have a good day.